Okay, hi everyone, thanks for coming. My name's Michael Maddern. I work in the automation BU on NSO, and I'm going to present this session with Scott Barvick from Ductus on Crosswork Brownfield development automation. Uh, what? Yeah, you can't. I'll talk louder. Is that better? Okay. All right, and yeah, thanks for coming, everyone. I know it's the last session, but I think we just ran through it, so we won't run over. So we're going to run through what is Brownfield, and for this session, we're really talking about putting your existing NSO services into CNC. So provisioning them, visualizing them, and assuring them. And then obviously, if you're used to using NSO, then when you introduce CNC, the scope's bigger. So then we look at how would you validate that, and that's what Scott's going to talk about and show a demo. So the goal here is for current NSO users to migrate to CNC, right, to the integrated solution that gives you the visualization and the assurance. Some of this has been covered in previous sessions last year. So last year here in the May developer days, we covered how to do that initial integration into CNC so you can provision your existing NSO services in CNC, and how you can visualize them on the topology. And then in December in New York, we had a session on service assurance and how you can add the heuristics. And for that in particular, Farouk, who's here, has got a session tomorrow. It's going to go into more detail. So, because we haven't got a very long session today and we're splitting it in two halves, so I'm just going to give a quick overview so you can see what's possible if you haven't seen this already. Just to give you an idea really, and then we'll follow up with the validation, which is the thing that's new today. So when we talk about existing services in NSO, usually if some people say legacy, so when we talk about legacy service, that often means without a plan. So those of you know, you have reactive fast map, and you can associate a plan, or you can use nano services to do it automatically. And when you have an NSO service in CNC, it needs the plan, right? Just know when the service is completed and when things happened, because the plan will send notifications. So that's the first point. And then there is this visualization framework for the CAT function pack. The CAT is the Crosswork Active Topology. It's just the acronym if you're not familiar with it, which is just the visualization. So you need to modify that. You need to modify the inventory plugin to say which services you want to see in CNC, and then the overlay plugin to say how to visualize it. And then finally, you have the service health, and this is with the heuristics package where you have rules and metrics, and from there, CNC will generate an assurance graph, which I'm going to show. So I'm going to show these things and then quickly how you can customize them. And again, yeah, I guess the thing I should have made clear perhaps is when we're talking about Brownfield, it's you already have the services in CNC. So obviously there's a whole challenge of getting them into NSO to start with, like the session yesterday morning. I think I went through that it was a good session, went through that in detail. So I think that's challenges we all know about already. But once they're in NSO, it's seeing those services in CNC, but then maybe provisioning new services in CNC using your NSO packages. So the thing with the plan, if you've already got the plan in NSO, then this step doesn't matter so much. But one of the things we developed a sample package called external plan that will give you the ability to add a plan to your legacy services. It's pretty straightforward. I'm going to show it in a second, but ultimately that will give you sort of the plan like you see on the right, and then in CNC you'll get like the tick to say, hey, the service is provisioned, and it'll show you what time it happened. So that's how that works. So you use this external plan package to attach the plan to your legacy service. You don't need to modify the service. You just define a link in between. Well, you need to define a plan. So you create a plan and say where it is, with the components, and then in the external plan package, you can link between list elements in your service to plan components. So, for example, that's on the next slide. So with the example L3 VPN service, you've got your main service, and you've got endpoints. So here, for each endpoint, we've got a CE device and a PE device. So you might want to generate a plan that gives you a component for each CE device and a component for each PE device. So right now, the plan and the notifications aren't generated for this service. You can then use the external plan service. The key is the path to the service, and then you give a path to the plan, and then you say what components you want. So for example, for the CE component, you say generate a CE component for every CE device and a PE endpoint component for every PE device. And when you instantiate that into NSO, it will then generate the plans for all your services, and it also creates kickers so that when you provision new services, the plan element will be generated. So, I mean, if you already know how to generate nano services and plans, you perhaps don't need to worry about this so much, but it's just a quick way of adding a plan to your existing service so you can use it in CNC. So the way it looks, if you've got, for example, if you've got the example L3 VPN service, currently in NSO, it's just a simple service using a NED to provision the devices below. What you need to do, so in CNC, we've got the CAT function pack SDK. So one thing you need to do in there is you update this service, this metadata file to say which services you want to visualize and see in CNC, and this inventory plugin to say what the paths are. And then you add the plan. So the plan data is then used in CNC, and the notifications. So the notifications are an automatic thing, right, that are sent from NSO. So CNC can just show some timestamps when things happen. So step one is to add the plan. And then step two is to update the inventory plugin. And I'll quickly show this in the demo. And then when you're updating the inventory plugin, you can also extend it by updating the overlay plugin. And this is where you describe how to visualize your service in CNC. So there's a few steps here. What we've got is an example in Java, but you can do it in Python. So you would start, there's a whole SDK you can install. So I mean, we could have there have been previous sessions on this in detail, so I'm just going to go very quickly through it, but feel free to look at the previous sessions if you want some more detail on this. But there's a create project function, so you create your project, you do your development. I'll quickly show some code in a minute. You build it, deploy it, and then once it's deployed, you can then test it and inspect it, and that's sort of what Scott's going to show, how you can validate it's working okay. So this is the kind of thing you can do. So this is how a service looks in CNC. Now, what's different here to like the sort of the example service you get from CNC, we've added. So normally CNC would only visualize the PEs. So you can see the CEs have been added here, and the route target is being shown as the service domain. So this is a slightly different visualization that I'll show again in the demo. But this is the kind of thing you do. And what you do is you define your service domains and then your edges and your nodes and how they link together. And actually, this is a bit more detail, just how the schema looks. I mean, don't worry about it too much, but this is sort of what you need to be aware about when you write some code to describe how these links work. So key things like your service domain here. So this is what we were showing as a route target. Then your edge devices, your service endpoint, and there's an API to go through and interact with this. And here's just the high-level workflow of how to do that. So if you're using Java, you need to generate the Java bindings, and then you update your package, build it, and then deploy it, as I just said. But yeah, there is Python too, so you can look at that too. The APIs for both. And then finally, the heuristic. So this is the last sort of piece of customization you can do. So this gives you the ability to add your own metrics to your services. So CNC can visualize them in the assurance graph. This is a fairly new feature in CNC. And you can monitor things like the device, CPU, memory, jitter, your SLA metrics, and then for the VPN, so the kind of thing we'll see is like your BPN neighbors, the session states, interface state, and you can define new rules for doing that, or you can use the built-in service metrics. So the way the Heuristic package works, you have your services, and then you'll create rules for those services, sub-services, so that will be things like your BGP neighbors, and then expressions, metrics. So as you can see here, for example, that your BGP session state is established. So there's lots of these already provided, and you can add more to your custom rules, and you can then create profiles to give different thresholds for when these things change. And then all of that is used in CNC to generate the assurance graph, which looks a bit like this. So here you can see, for example, for an L2 VPN service, you've got a subservice of the VPWS, and then down here you can see things like the neighbor health. So that's all the slides I wanted to show. I'll quickly go into a demo. I just recorded this morning, and we could show it live, but just in the interest of time, and I don't want anything to go wrong with connectivity, so I'm just going to play this. So so starting in NSO, just looking at this external plan package. Let me just pause this a second. So I'm just going to go through those things we saw in the slide. So just how the external plan package is used, how that looks in CNC, how the visualization looks, and then how the assurance graph looks. So first of all, you look at the external plan. So inside here, we say where our service is and then where the plan is for that service. So you need to have the plan. And then, as I said on the slides earlier, you can define components, so a PE endpoint, and in there you've got a dependency with a path to what that depends on. And then when you instantiate this external plan service, it's going to go find all those services, generate plans for them all. As long as they're provisioned, they will all be set to reached. So we've got one service called test one. This environment that I just recorded this demo on, it's the same environment Scott's going to use later. You'll see the same service there, this same test one service. So this is how it looks in NSO. It's already provisioned. I didn't want to go through the steps of actually provisioning it. I mean, that just works. It's got 2 endpoints, node 4 and node 5. And what we want to do is see this in CNC. So what you need to do with the SDK, first thing, you can update this service metadata, and you just provide a few simple things here, like the service path, the plan path, the assurance, a few basic parameters. This is all documented in the SDK documentation. And then in the inventory plugin, you just need to provide which services you want to see in CNC with the path for the service and the plan. And that's when you go into the provisioning UI in CNC, you'll see those services. And that UI, a bit like NSO, it's auto-generated. So all you need is what we just saw there, and then you'll be able to go in and it'll generate some forms if you were actually going to go in and do the provisioning. So this is the CNC UI. I'm going to switch to the provisioning UI. And we can see there's the service, right? It's appearing, it's provisioned. You can see the time it was provisioned and that it's green, and that's come from the plan data. And I could go through and provision that too, but it works. And then you click on that and drill down into the view in CNC. So again, this is a custom visualization. It's got 2 nodes, and it's using the route target as the service domain, as we saw in the slide earlier. And you see custom attributes when you hover over it. So the way that works, just to show you quickly, so in the overlay plugin, and again, you could do this in Python, but in Java, there's a well-documented API, which I'll scroll through here, that I haven't got the class path defined properly. That's why the errors are at the bottom. You can ignore that. And yeah, you just go in here and define what attributes you want to see, what links there are. This is the line that defines the service domain and how it's linked to the endpoints. And then finally, we can see the assurance of the monitoring. So we're using this gold demo L3 VPN config profile. So this is coming from the heuristics package that I'm going into here. It's a custom profile, so you can see the profiles here. This is the gold one. So this is what contains the thresholds for the rules. So in here, you can see what rules are being used, the L3 VPN demo rule, and then the thresholds that will be used by that rule. If I go into the L3PN demo, there's various subservices in here. So this is where you've got your CEP, root health, your neighbor health, things like that, interface health. So whether your interface is up or not. So this one here, for example, this subservice, interface health. So these can be custom subservices that you've added, or they can come from the system subservices, which that one does. So as I'm opening up here all the system subservices, you'll see the interface health. And then how this works is you've got the expressions that we saw on the slide earlier. Your expression is upper up and low in errors and low in discards, and then you can drill down further and see upper up is that expression, and you can drill all the way down to what you need. And again, Farouk's going to cover this in his session, but you can export these and edit them and re-import them, and that's how you would update that for your own use. And then I switch back to the VPN services, and we'll just take a look at how that assurance graph looks, so how it's generated with those metrics. What you have is a node for each metric below the service. So we've got our test one service, and there's the subservices. You can show dependencies, so we can see the interface health, for example, that we talked about earlier, is dependent on the device health. And I think really with that, because we haven't got much time, I'm going to stop here and then hand over to Scott, and he can go on to show how we validate all of this.
All right, so thank you. Thanks, Michael.
Switch back to the slides.
And just remember everything that he did by hand, and think about doing that by hand. And so this is what I'm doing today. Poll for, again, the state of the art. Talk about why we do this in an automated fashion, and then how. That's the good news, because we can. It's right at your fingertips. In fact, we're doing it. We're doing all the pieces already with NSO, and Crosswork is a natural extension. Just a much bigger extension. And then, of course, there's a demo, so we'll do that. Okay, so this was going to be a poll, but just based on everything, I just wanted to throw up some things that could have been in the poll, and you can just look at these and say, are we using any of these tools? And if anybody has any tools that you don't see on this list, I wouldn't mind hearing about them for testing, for your automated NSO testing. This is the set of things that we end up using all the time, and it depends on each customer situation. So, assuming that this is pretty much a good view of things, again, there might be some other ones. I heard about one today, with Behave. That could be another one. Yeah, that was a very good presentation. So so the universe is big, but really you'll see that it all can be applied. Okay, so now we're the why. So NSO used to be the system. We talk about NSO testing all the time, and but now look at it. It's just one little component in the big Crosswork universe. So with that, we say, well, okay, yeah, NSO is there, and I'm testing it. Yeah, because why? I'm adding services. I'm doing software. I'm making models, and prior to perhaps Michael's talk today, you might not have known that all of those things end up being things you do in Crosswork. Sometimes you see that picture and you say, oh, NSO fits in here, and what you have is a Crosswork. It's kind of done, and it just absorbs this stuff and does all the right things. But you saw all the pieces that go into getting a service into Crosswork. And in fact, there's models coming from the top as well, and then service assurance, and now we learned yesterday about workflow. So Crosswork's a big thing, and so I guess I forgot about the slides. So so CNC is a big scope, and far larger. So clearly we want to verify what we did, and certainly from the data point of view, but also from the SDK and deploy PRJ and the models and the Yangs and things like that. Those things are in there, and those feed the machine. And even if the machine is perfect, the data that feeds it has to be correct. And so there's a reason to then go verify on the Crosswork system. A big part now, we don't all use the NSO UI, but that's very much a data-driven thing and kind of more straightforward. But we have some very active topology and service assurance UIs out there, driven by data, driven by the models. And so we really want to make sure that at the very least the data that's driving them is doing the right things, but also some of the operations, and you'll see that in action. And then big picture, the intent-based operation is it requires a deep understanding of how the whole system's working, and by feeding it with deterministic inputs, and then watching the results is a thing that you can do. So my quote, lots of quotes this couple days. My quote is hope is not a strategy, and a lot of people have said it. I couldn't find the original source, but these days with some of the big software, I don't think enough people are saying it, and so hope is not a strategy. Okay, so that's the why. Now how? How do we test NSO and CNC? Well, guess what? The answer is pretty much what you're doing already, but add to it and then think and then think about how you're going to verify some of these unique components of CNC. So this is kind of the overall scope. So when we start off, clearly we're going to verify the initial state, right? I mean, most tests you're going to start with your initial state. Usually it's a good state, and so, but you're going to go check it on the NSO and CNC, but also from the topology visualization and the surface assurance point of view. So, that's kind of, this is all going to be very straightforward, but really it will then feed into the demo and you can see how you might accomplish all this. All right, so in order to drive activity in CNC, we're going to cause a network incident. You saw from Michael's part of it, all the different ways that you can drive service assurance to do something different, and from the different models from BGP to a network interface to then other things. And so we're going to cause a network incident on the NSO that then feeds its way northbound. First thing we do, of course, is verify that what we thought we were doing is actually doing something on the NSO, because if not, it's not going to happen probably northbound. But then we go into the CNC and we go check these things out, and then we'll just make sure they're verified. And then, of course, we're going to put everything back. We want to get back to the initial state, and not only just, hey, so the next test can run from a known state, but also the recovery of CNC is an active event, and so you need to make sure that does the right thing. Well, right, you start by repairing it, and then you go verify across the whole system. So that is essentially the sequence, and of course this is one slice straight up through these components that we're talking about. If you remember the whole architecture, the scope can be enormous, and so obviously what you want to do is start with some best practices, all of the same things that we learned with NSO, and of course the big pitch is embrace automated testing. I think as you watched Michael do this, and this is what I did when I first got my hands on a CNC. You go and you say, hey, the model's in place. Look at the topology. Yeah, looks okay. Go surface assurance. Looks okay. But okay, now do that again tomorrow and the next day. So automated testing, it's got to be the way. And starting simply. We already have the NSO tests, right? They live at the base of this whole thing. Start with those. See what they do to CNC, and then verify that, lock that in. Another one is go broad first. I like that because it lets you know if things have just really broken. If you get in and if I wrote 10 tests for this network event, that's good. I mean, I'll find the minute issues. But if I have a whole set of things where I verify against BGP or other sorts of data, did I find that my network collector is down or something like that? So that's how I like to do things. But I mean, that's almost a preference. But then a big one here to help get you going is leveraging the infrastructure work of others, and that's whether it's open source or things your teams have already done. If you want to bring down some BGP peers, you might have some things to do that, or bring up some interfaces, deploy some things. You might already have that sitting around, so you don't have to start from scratch to have the infrastructure that drives all this stuff. So lower level, the digital twin, the test setup, you really need that. You're not going to be doing some of these tests against a production system. So I mean that kind of goes without saying. Automate the cleanup and reset. This is one that drives me crazy when you have to do 10 things by hand, taking 20 minutes in order to run a big test. we had a situation where we had to do that on that project here. So make sure that you take that extra step, and so you can automate the full cleanup and reset, so you can get back to that initial state. And then to inject, we start with NSO, but the next thing is, I think Michael said it, you can create some services in CNC, and then watch how that spreads out and ends up, throughout, both through surface assurance, the topology, and then down to the down to NSO. Okay, so with that, I think we are ready for a demo. Okay, so I also have recorded it. I thought some of the recorded demos went very well. We actually could cross our fingers and run this live, but we're not going to do that. So what I'm going to do is, up here in the top, you see this is so my tool of choice is Robot, and so you'll see the familiar green success things from Robot up there. Over there on your right, you'll see an NSO terminal, and that is just so you can see that things are happening on the NSO. We're just going to watch the commits happen. Not going to do much with that at all. And then we got some stuff here, but we're going to end up popping the Crosswork UI and driving that dynamically with Selenium through Robot. So that's kind of the scope. And the good thing with the recording is that I can fast forward through. So here we're going to start at the top. We're going to kick off the robot test, and first thing it's going to do is make sure we're going to pop open the CNC UI. We just have to do that. And I'm going to, with a recording, I can fast forward through this, which is kind of good because it's a little bit slow. And then, so it has, all right, so it has then popped open the CNC UI, and what you have here is the same topology, I believe, it should be, as what Michael showed. And the first thing that the test does is verify that the topology is correct. And that's almost an initial state, but it's also a verification of the third party, or the external plan feeding the right data, the Brownfield service feeding the right data off into Crosswork, and then it properly rendering it. I think I'm not sure there's a REST API for this. I mean, one feedback would be the more REST API access into the data models, because we're going to do this through Selenium, and that's a little, that's great. I trust the rendering. I trust the rendering of the JavaScript modules that do it, but the data has to be correct. So anyway, so that's interesting. All right, so I will start to play. So what we're going to do is we're going to walk through this. Then I brought down the screen, so it should properly render the VPN topology. And so it's going to walk through. It's going to hit every node, and it's going to go over and check some stuff there. And you can just do that. So while that's happening, it doesn't take that long. So this is, again, initial state plus some, making sure that was correct. And so the next thing will be, okay, well, actually the initial state is then going to go check the service assurance. There is an API for that, a REST API. And then, so this should have no degraded nodes reported in the service. It's actually checked through the REST API, and it's also going to walk the visualization in service assurance. And so you can see that popping away down there. I'll put this over here. And it's just walking them all. Okay. And so now it says test should simulate a network event. So this is where we're going to go hit NSO, watch the commits, and then we can watch Crosswork do its thing. Did we get the? Yeah. So we just brought down an interface. It's kind of small, but there's a service assurance metric and rule set that is looking at for the interface health, and so it's going to failed to get that properly. And so you see some nice UI stuff happening. I guess I could go faster through this. We will get you there on time. Yep, so we got the degraded event, and it's going to just prove that. And so now the next thing, okay, so that was a success. And now it's going to bring back the interface. And again, all the stuff has to happen when the network heals itself or the network is healed. So you want to make sure you verify that. And I'm just going to hit the fast forward button because it's going to heal it in NSO, and then it's going to check the APIs, including the UI, and make sure that, I guess, there we go, and make sure that happens. So it's kind of neat when that pops back into place. So I think that is all. All was green. It all worked. And maybe, I don't know, I think we're now ready for any questions you might have. Michael, if you could come back up here and see if there are any questions. That is it. Okay.
No questions?
What?
Question?
So we these days we see a lot of robot and certainly a lot of PyTest. We actually have we built on. I like robot. I choose it when I get to because it has a nice high level user tester interface. Plus, very easily you can drop right into Python and do anything you want really in Python. If it's, my rule is as soon as it gets ugly in robot, because it doesn't loop well and it doesn't do some variables as well. It does them, but it looks kind of ugly as soon as you do too much. So you just drop into Python and do whatever you want.
So when you simulated the Brownfield VPN service, the legacy, did you connect to an existing NSO installation, or did you put the legacy service package on the NSO that comes with CNC?
Into the NSO that comes with CNC.
Is this the correct procedure?
Yeah. Yes. So you certainly can use the same NSO instance. Yeah. Yes. I think really it's something that depends on the customer and how many devices they have, how many services, what the services are, if they'll work with what CNC is providing. But yeah, you can certainly do it. Definitely. I think that's the easiest way for sure. Yeah, and in this case, definitely, it's all inside one NSO. I think it was just based on the VPN packages that come with CNC. There was a flat L3 VPN. I think that's deprecated now. It's the IETF VPN. So what we showed in here was just taking the much simpler example that comes with an NSO. You probably all know it, right? The example's NCS VPN, and just deploying that on the NSO that comes with CNC, and then adding to visualizing it. So yeah. Same NSO.
Great. Oh, yep.
Yes.
How much of this customization depends on the actual Brownfield service on NSO? How much is it like straightforward?
Yeah.
How much do you need to?
So for the plan part, that's pretty simple, right? You don't even need any components. You just need something where the self says when it's done, and then and you need to update that inventory plugin just to say which services you want to see. I think the more complex part is how you want to visualize your services, where you do need to write some code if you want to see the service, on the overlay. But just as far as the external plan, that's just an easy way if you don't already have a plan of just getting a service there that will generate plans for you automatically for those legacy services. But all you need is for when you add the service into CNC, two things. You need to say the XPath for the service and the XPath for the plan, and the plan needs to go to the ready state for it to go green in CNC. It's as simple as that. You don't need any more detail. The visualization on the map, you mean like this? No, you do need to. So unless you're, so there's two things, right? One is if you're introducing a completely different service into NSO than what it, into CNC than it already has, then you absolutely have to write all of the code for it to know how to visualize it. You can also take, say, for example, the IETF VPN model that CNC already supports, and maybe you want to make some changes, add some new nodes or something, and in that case, you might need to make some slight changes to get this to work. But it won't, if you just introduce a new like eVPN service or something, it won't visualize it unless you add, you need to tell it, what are your nodes, what's your service domain, what are your connections. It's not going to know that otherwise. But yeah, it's all documented in the API. It's fairly straightforward, especially if you're a developer. Does that answer okay? Yeah, okay.
Yeah, we're around if anybody has any questions.
Yeah.
Which libraries? I don't think so, because I didn't know. Yeah. Yep. No, that's certainly a thing. I think it's even on my list of tools. Absolutely, one wants to do that. This is with the dcloud because it's new and it was there. Yeah. So haven't driven it through a CI/CD pipeline yet.
But it's a good point. Yep. Yeah, we should definitely look into that. I think because it's something we do with NSO all the time, right?
Absolutely,
but it gets a lot more complicated with the CNC.
Right.
Yes. Oh, yes. Well, it's just the fact that for CNC, you need to have a plan for it to work. And I think we're just saying it's easier if you just use a nano service rather than programmatically define your plan, with reactive fast map. But as long as you've got the plan, and that's the whole point of this external plan package. I mean, it's just a POC. You can download it, but it just lets you add the plan without modifying your service. So I mean that's
the external plan has two pieces. I mean, one is the ready state, the plan data, but also notifications. And I think the two work together to tell CNC that we are ready, we are here. Yeah. And so whether you do that, I mean the whole point of all this is the legacy service doesn't do any of that. Yeah. And so you just need this thing to kick it and send a notification and represent it toward northbound.
Yeah, I mean maybe it's all a little bit too much detail to go through, but we just wanted, I mean, this is real, right? This is how you do it, and just show that it is possible.
Absolutely. Thank you, everybody.
Okay.
Thanks.
Right.